Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 18 of the March daily LeetCode challenge, and we again have a medium question. This question is going to be on the topic of bit manipulation. Yesterday also we had a question which was like marked as a manipulation question, but we solved it in a different way. Okay, we actually like focused on why this cannot be solved on bit manipulation. For yesterday's question, we focused on that, but today's question is a pure bit manipulation question. Okay, and we will approach it in the same way. So it is question 2401, longest nice subarray. Okay. Yeah, so the question, see, I am again it's same thing. I will expect that you go through the question, read it. I will just highlight some of the important points here. Okay. So the question is, see, idea is we have to select the longest subarray. Let us say this is a subarray. So in this, what will happen is each pair. Okay. Let us say, see, currently I'm highlighting a subarray of length 3. Okay. This is a subarray of length 3. What should happen is this will be called as a nice subarray. Okay. This is the term defined here. This will be called as a nice subarray if the pairwise bit. Okay. That is a pairwise bitwise AND. Okay, in this case if you see, for each pair if you do the bitwise AND, the result should come as 0. Okay, let us say this is my set. Okay, 3 8 and 48. Okay, first of all, the subarray means it has to be contiguous. Okay, remember that. I'm not talking about subsequence. This is a subarray. This question is about subarray. Okay, subarray basically means that all the elements should be contiguous in the original array. Okay, as simple as that. Now in this case if you see, this particular subarray has 3 elements. Okay, so now like form all possible pairs. Okay, so 3 and 8 can be a pair, 4 and 48, sorry, 8 and 48 can be a pair. Similarly, 3 and 48 can be a pair. For all these pairs, the bitwise AND should be resulting into 0. Okay. So for the individual bitwise ANDs, for each possible pair in this subarray should be resulting 0. If that is the case, then we'll see that this is a nice subarray. Okay. And the question is about returning the longest nice subarray. Okay. I will again repeat. First of all, like see the question in the very basic part. You have to take a subarray. Okay, any subarray of any length you can take. Obviously, like obviously all the subarrays of length 1 are going to be nice, that is sure. Okay, the answer, minimum answer possible in this case is going to be 1, that we all know, right? But above that, okay, any subarray of length greater than 1, what you have to do is take the subarray, try to form all possible pairs. Okay, when I say pair, what does that means? Pair means every number can be paired up with another number. Okay, any other number. Okay, as simple as that. They need not be adjacent or anything like that. Any number in this particular subarray can be paired with any other number. Try to form all such pairs. Among all such, like for all those pairs, the bitwise AND should be resulting into 0. Okay, if that is the case, then we'll say this is a nice array. And similarly, for all such nice arrays, what you have to do is you have to return the length of the longest nice array. Okay, that is the question. You can think about how to solve it in a brute force way, but I will show you a O of n solution. Okay, how to do that? So it is going to be very simple. First of all, you have to observe what is happening. See this, let us say this is my subarray. Okay, my subarray has 3 elements, 1, 3 and 4. For each one of them, I'm showing you their bit representation. Okay, they are binary representation. Okay, so these are the bits. Okay, so if you're not aware of what these bits are, I will request that please go and study what is 2's complement and all those tests. Like just understand what is the basic meaning. But the idea here is each one of them has a place value. For example, the digit here, the value that I'm highlighting here has a place value of 8. Similarly, the value here has a place value of 4. Similarly, this is the place value of 2, and yeah, that's this one, yeah, has a place value of 2, and the last one has a place value of 1. Okay, so it is like 2 power 0, 2 power 1, 2 power 2, and 2 power 3, and so on. Okay, like this it will be going on moving. Okay, as simple as that. So there is a concept of LSB and MSB. MSB is the most significant bit, and the this is the rightmost bit is called the least significant bit. Okay, because it is contributing the least possible to the final value. Okay, simple as that. So now, so try to understand what is happening. Let us say this is my array. Now I want to ensure how to ensure that each bitwise AND operation for each possible pair is resulting into a 0. So see, when it will result into 0, first of all, what is AND operation? AND operation means that, okay, let us say there are two bits. Okay, the bit is A and B. Let us say the bitwise AND of this should result into 0. Okay, how to ensure that? This will only happen if, let us say, both of them are 0. This first condition. Let me write the AND symbol also here so that you understand properly. When will this happen? Okay, when this condition will be true. The first case is when both of them are 0, or any one of them are 0. Okay, this is the case. See, at least one of them has to be 0. Okay, at least A or B has to be 0. Okay, I am assuming you are getting my point. Okay, at least A or B has to be 0, which obviously means both of them can also be 0. Okay, even if both of them are 0, that is fine, but at least one has to be 0. Okay, that is the basic idea, right? So that's what we are going to ensure now. See, since here only two numbers are involved. Okay, only two numbers are involved, and since, see, you have to understand in the bitwise level. Okay, each bit is being, and operation is happening in the bitwise level. Okay, for example, when I do AND of 1 and 3, for each bit position the AND operation will be happening. Okay, it is a bitwise operation for each position. Okay, so for each position we'll have to ensure that the result comes 0. So in this case, if you see here, this particular bit is set in this. Okay, but for other two numbers, that is 3 and 4, if you see, this particular bit is not set. Okay, similarly, if you see for number 3, the second bit is set here. Okay, but for the other two numbers, the second bit is not set. Similarly, if you see for the number 4, only the third bit is set. Third bit from the right is set, but for the other two numbers, the third bit is not set. Okay, similarly here all the values are 0. Okay, all the fourth bit from the right is 0 for all the numbers. Okay, so that is how we have to ensure that the bitwise end of each of them is resulting to 0. Okay, so what you have to do, it's very simple. Idea here is overall number of bits set for each position should be at most 1. Okay, what that means, see, this is the position number 1. Okay, in this position number 1, at least, okay, I'm not at least, it should be at most 1 should be set. Okay, one bit in one of the numbers should be set as 1. Let's say this is my window. Okay, my window has 1, 3 and 4. Okay, now among these I will go through the bit number 1 of all of them. Only if, among all of them, only if one of the number has the bit set, then that is fine. If more than one number has that particular bit set, then it is not fine at all. I will again repeat. Let us say this is my window. Okay, let us say this is my window. So what I will do in this, I will go through, let us say, the bit number 1. Okay, first I will go through the bit number 1, that is this particular bit for all the numbers. Okay, the first bit for all of them. Okay, I will go through the first bit of all these three numbers. Okay, now if all these bits are 0, that is the first bit of all of these numbers are 0, that is, well and good. But if at least for one of them, at most for one of them the first bit is set to 1, then also it is okay. But if more than one bit has, let's say, more than one number has this particular bit set, then it will be a problem. That means at least in one of the ends that you are going to do, you will not get a 0. Okay, that is why overall number of bits for each position should be at most 1. Okay, the number of set bits for each position should be at most 1. Beyond that it should not be set, because see, we have to, that's why I mentioned, like, at least one of them should be 0. Okay, so even if one of them is 1, the other should be 0. Okay, that is why we are saying at most it should be 1, because beyond that it will not be possible for us to, make it 0 with the AND operation. Okay, simple as that. So that's what we are going to do basically in this. I'm going to use a sliding window approach. Let's see what we are doing. Okay, so I'm first of all creating a default dictionary. Here the keys will be the bit positions and the values will be the frequency of bit set. Okay, in this particular window, that is, let us say this is my window. In this window, what will happen is, I will, like, see, this is something like this. Let me, like, write it here. The keys are going to be, the bit positions. Okay, the the position of the bit, and the value is going to be the frequency. Okay? The value is going to be the frequency. Like, frequency means that, like, this particular bit is set in how many of the numbers in the window. Okay, simple as that. So this, okay, just a second. Yeah, this is a position of the bit, and the value is going to be the frequency. The frequency means, like, for this particular bit is set in how many numbers in the my current window. Okay, so I'm capturing the length. The answer, see, as I mentioned, always the answer is going to be, but the minimum answer is going to be 1 always, because, see, always any subset of length 1 is always going to be nice. Okay, simple as that. So this is a function. Okay, what this function will do, let me quickly show you. So the idea is going to be very simple. See, because this, is, defined at a global level. Okay. So what I will do is, I will just pass a value here. Okay. I will just pass a value. What will happen is, see, the code start from here. I will go to, okay. Okay. One more thing that I should have showed you starting is, see. So the maximum number that can come is, C 10 power 9. Okay. The maximum number that can come is 10 power 9. So we need to know, like, how many bits will be required to store this particular big number. Okay. So I'm doing 2 power n is equal to, see, these things no one will show you. I'm telling you, this thing no one will show you. But if you do, see, this kind of calculation you should be doing in a interview. Okay. Otherwise, like, how you are knowing, like, 30 bits should be enough to store all that. Okay, in some solutions they will be simply saying, okay, 30 bits should be enough to store this. But how you are knowing that, where is the calculation for that? Those things are also important. Okay, so this thing you have to show. So see, here is the calculation. 2 power n is equal to 10 power 9. Okay, this is not exact equal to, this is like approximation equal to. Okay, then I'm applying log 10 on both sides, so it will become n log 2 and this will become 9. Okay, and then if you solve it, you will get n equal to 29 point something. We have to always take the ceiling of it. Okay, remember, you have to always take the ceiling of it. Okay, so ceiling of this is going to be 30. So approx, that is, idea here is to show this much big value, we need at least 30 bits. Okay, simple as that. So in my calculations, if you see, always I will be revolving around the bit of 30. Okay, that is 0 to 29. Okay, simple as that. So what I'm doing, see, this particular calculation is the right shift. Okay, I'm right shifting the place by I. What is the use of this? See, what I'm trying to do is, I'm trying to check whether each of the bits, okay, that is the first, I'm talking about the first 30 bits from the right. Okay, I'm trying to check if each one of them is, how many of them is 1. Okay, how many of them are 1. So I am, right shifting them one by one. Okay, like, first right shift will be 0 times, like, right shift by 0, then it will be right shift by 1 and right shift by 2. So what I'm trying to do is, see, if I right shift by 0, this particular bit will be set. Okay, similarly, if I right shift by 1, this bit will be in the ones place. Okay, similarly, if I right shift by 2, this particular bit will come in the, yeah, this particular bit will come in the zeroth place. Similarly, if I right shift by 3, this particular bit will come in the zeroth place. So which are in the zeroth place? Okay, I am trying to do and of that with 1. Okay, I'm trying to do and of that with 1. Okay, so and of that will result into 1 only if that particular bit is set. Okay, so this will ensure that the ith bit of the number is set or not. Okay, if this condition is true, that means the ith bit of the number is set. If the number is set, what you have to do, you have to go to the ith key and we have to increment that by 1. Okay, as simple as that, right? So whenever incrementing, see, that's what we are checking. If the, frequency of that goes above 1. Okay, if the frequency of that goes above 1, that means the current window that we have, is not going to be a nice array. Okay, so we have to make this as false. Okay, this I'm writing here is, if it is already false, you don't have to check this condition. If it is not already false, then only check this condition, and if both of these are true, then come and make this as a false. Okay, at last we are returning the value. Okay, that is, if after adding, see what we are doing is, for each number I'm going to add it to my window. After adding something, we are just trying to see if our window is still resulting into a nice subarray or not. Okay, if it is not a nice subarray, we'll have to start, see, there is expansion phase, there is going to be contraction phase, so I'm going to show both. Similarly, this is the one where we are trying to do the contraction means we will be removing each element now. Okay, in this case, if you see, we were adding that. Okay, we are adding one to the existing frequency. In this case, we'll be subtracting one to the existing frequency. Okay, rest of the code is same. Okay, this code and this code are exactly same. Only difference is, here we are doing a plus one. Okay, because we are adding a number. Here we are doing a minus one because we are removing a number from the window. Okay, this will execute it if we are adding a new number to our window. This code will execute it if we are removing a number from the window. Okay, as simple as that. So decrement the frequency of all the set bits of the val is this particular value. Okay, I'm talking about this. Similarly, this will be increment frequency of all the set bits of val. Okay, now this why I need this. The idea here is, whenever I want to remove a number from the window, this value will be passed as a false. Okay, so when this value is false, we have to remove the past value from the, like, we have to remove the set bits of the past value from our this particular dictionary. Okay, simple as that. If this value is 2, which is by default it is 2, what we have to do, the value that is passed, take all the bits of that, all the set bits of that, and increment the corresponding with frequencies. Okay, simple as that. So this is the main function. So it is basically a sliding window approach where the window length is going to be variable. Okay, now L equal to 0 and R equal to 0 initially, then this loop will continue till L is less than equal to R and R is less than N. Okay, what is N? N is going to be the length of the nums. Okay, simple as that. Right, what we are doing, see, this is the expansion phase. See, what I'm doing is, I am trying to add the nums of R. Okay, nums of R, see, always the expansion will be from the right, the contraction will be from the left. Okay, so I'm adding the nums of R to the window. Okay, I'm passing true here. True means that, see, already it is true, you need not pass true here. Okay, you can even remove this part, still it will work the same, but yeah, just for reference I'm passing it. Okay, so what this means is, then this part of the code will execute it. Okay, that is the basic idea. For every set bit of that number, the corresponding bits will be, like, the corresponding keys will be incremented by one. Okay, the value of the corresponding keys will be incremented by one. Okay, so what we are doing, see, I'm calling this function. If this function returns true, that means what you have to do, we have to expand the window further. Okay, I'm incrementing R, and see, since we have, see, idea here is, currently the subarray that we have, it is going to be one of the possible answers. So I'm recording the length of the subarray. Okay, because, see, this value is returning true means, see, whenever this function returns true, that means the current subarray that we have, that is the current window that we have, is basically a subarray which is a nice subarray. Okay, which is satisfying this condition. Okay, yeah, nice subarray, that is what I'm trying to tell you. Okay, in that case, you have to record the answer. Okay, initially the answer is set to 1. Okay, as you can see, initially the answer is set to 1, and what we are doing next is, we are doing this. Okay, answer equal to the previous answer, comma, R of L. Okay, among them, whichever is the maximum, that's, see, R minus S is the current length window. Okay, always remember that R minus S is the current length window. Okay, the way it is defined, see, initially R is 0, we are incrementing by 1, like, while this condition is 2, only then we are incrementing this by 1, and we are taking the R minus L after that. Okay, so the way the things are defined, what this happening is, this particular value is telling you the length of the current window. Okay, as simple as that. So we are recording that to our answer. Next is, let us say this condition is not true. What is happening, see, we have added the new number. Okay, this particular number got added, but what we got to know is, after adding this number, current subarray that we have is not a nice subarray. Okay, because after this addition, after adding this number, what happened is, now we got to know that the current subarray is not nice. So we'll have to start the contraction phase. Okay, so contract the window. So how the contraction will happen? Contraction will happen always from the left. Okay, that is the leftmost element in our window should be removed. So what I'm doing, so the leftmost element of the window, okay, this should be removed. Okay, here if you see, I'm passing the value false. Okay, function is the same, this is the same function, but here nums of L is passed. Remember, here nums of R was passed. Okay, here nums of L is passed and the value false is passed. So value false is passed means this condition will be becoming true and this code will be executed. Okay, what this code does, this code again does the same thing. For this particular val, all the set bits are all the set bits are first of all identified, and the corresponding keys are decremented. Okay, the values of the corresponding keys are decremented, and if any position, if any point, we got to know that still after, see, even after decrementing, if we got to know, like, the some of the bits are still greater than 1. Okay, like, for some of the bit, the frequency is still greater than 1. Okay, some of the bit positions, the frequency is still greater than 1. In that case, again, we will return false. Okay, that is idea here is, even after removing the leftmost element, still we got to know that the array is, the subarray is still not a nice array. Okay, so we will return false again. Okay, else similar to that. So if this particular function still returns a false, that means we will have to still do the contraction. Okay, we have to still keep removing the elements from the left. Okay, in that case, what you have to do, you have to do L plus 1, and you have to again keep removing the element. Okay, as simple as that. Let us say this condition becomes, this condition, okay, returns a true, this function returns a true. So true is equal to false will be again a false condition. So if this function returns a true, basically we will come out of this particular loop. Okay, we have to do L plus 1. Okay, because remember, when we started the contraction, okay, we did not do L plus 1. Okay, if you see here, we have not done any L plus 1. That's why after coming out of this while loop, we will do L plus 1 first of all. Okay, then see, these are the print statements that you can add them. Okay, you can basically add them. When I added them, okay, I will add them and show you the output also. But yeah, like when I was tracing it, I was adding the statements. So currently I've commented them out because I have to summarize the solution. I will advise you that please remove this print statements. I mean, remove the comment from this print statements like this and try to see how it is working. Okay, this will be very helpful for you to understand. Okay, now, since the window now that we have, okay, after this particular code, the window that now we have is going to be a nice window. Okay, so we have to do R plus 1. Okay, and then we have to again take the answer. Okay, as simple as that. Always remember, after doing R plus 1, we are taking the answer always, because the way it is defined, it is working like this. Okay, always take, after increment the R, we have to take the answer. Okay, similarly here, after increment the R, we have to take the answer. Okay, simple as that. So basically, increment R basically means that we are again in the next iteration, we are trying to expand the window. Okay, as simple as that. So this will keep continuing till the initial entry conditions are true for this while loop. What are the entry conditions? L is less than equal to y. This condition will be again always true only. Okay, because the way the nature of the question, no, always of any window of length 1 will always be a true. Okay, so this code will always see. That's why if you see here, no, here in this while loop, I'm not writing like L is less than equal to y. All those things I'm not writing. There is no need for it, because always whenever a single element is left in the window, always for that the it will be a nice subarray only. Okay, so don't have to worry when L will cross R and all that. Okay, that will not happen. Okay, normally this is just for your understanding, I'm writing it. Again, this should not be needed according to me. Okay, this should not be needed. Okay, so this is the main condition because of which the loop will stop, and after the loop stops, we have to come and return the answer. Okay, as simple as that. So I should have shown you the, I'm not sure if it, okay, let me try this now. Let me remove the comment print statements and show it to you how the output appears, so that I can trace and show it to you once. But again, I'm not sure because of the internet error. If this doesn't work, I cannot help in that. Okay, so let me try, but again, I am cannot assure of that. Okay, I have removed it. Let me run now. If the output comes, I will definitely explain it. Otherwise, okay, the output came. So as you can see in the first example, what is happening? See, this is our original window. Okay, we added the first element. As you can see, it's got added. Then we added the second element. Okay, the second element got added. After this, we realized, okay, the subarray that we have, okay, this particular subarray is not satisfying. This is not a nice subarray. Okay, so what we have to do? We have to start contractions. Can you tell me why this is not a nice subarray? See, the first bit is set in 1. Similarly, the first bit is set in 3 also. Okay, that is the reason why this is not a nice subarray, because if you do a AND of 1 and 3, you will not get 0. Okay, that is the basic idea. Okay, if you do AND of 1 and 3, you will get 1. Okay, try to do that and see, you will get 1. Okay, so that is the reason why we have to contact. Always contraction will happen from the left. Okay, that is, this is the current window. Okay, this is the current window. The first one will be removed, so only 3 will be left. Okay, after that, what we are doing now, we will again start adding. Okay, so 8 will be added next, so it became 3 and 8. Now this particular part is a nice area. Okay, so this could be one of the possible answers. So answer now become 2. Okay, initially the answer was 1. At this step, it will become 2. Okay, similarly, the next element will be added. Now 48 will be added. Okay, so as you can see, now the 48 got added. Now at this point, again, this is a nice array, so we are now answer will become 3. Okay, now because this is the length of the array is 3, right? Next, we added 10 also, but at that moment we got to realize that no, this is not a nice array anymore, so we have to start the contraction phase. So we removed this 3. Okay, this particular 3 will be now removed. Okay, as you can see, the contraction has started for this array, and 3 got removed. Okay, the 3 that was here got removed now, so this is the array left. Okay, now again, we have to remove the 8 also. Okay, after that, only 48 and 10 are left. Okay, so they are claiming that this is something like okay, this is one of the possible answers, but since we have already seen an answer of length 3, so we will not go for the answer of length 2. Okay, so final answer is going to be the max of the sub array that we have seen, which is nice. So answer is going to be 3. Okay, in this case, right? So yep, that was all. Yeah, in the example number 2, it is a, see, example number 2, the answer is going to be 1. That means none of the pairs are going to form a subarray, which is of which is nice. Okay, as you can see, 3, we added 1, we realized it is not fine, we have to remove. We are removing 3, and it is left to 1. We added the 5, it is again not nice. 1 got removed, it is left to 5. Similarly, 11 got added. Okay, 5 got removed. Okay, similarly, 13 got added, 11 got removed. Okay, at last we have 13. So always, if you see, all the valid subarrays, all the valid nice subarrays are of length 1 only, so you have to remove return 1 as the answer. Okay, as simple as that. So yep, that was all for this question, friends. So this was a really nice question. Okay, so the thing is, you should be aware of the bitwise. If you are aware of how the bitwise operator works, how those things are done, especially this part, right, the way that I have done. Okay, so what I'm doing is, see, these things you will get to know only with practice. I understand that if you are some a beginner, then definitely this is not the right question to start learning the bitwise things, because this question already has a complex, like this question definitely requires a basic to slightly have a understand slightly more than average understanding of the concepts. But again, the idea is very simple. Try to learn bit by bit, that is try to learn part by part, like what is happening in this part, what is happening in the other part. Try to learn small part by part, only then you will understand the whole solution. Okay. And always remember, in bitwise you have to always maintain notes. If you're not maintaining your notes, you will again forget very frequently. Okay. So see, in this case what is happening now, we are right shifting. Okay. So I want to know whether each bit, okay, see, the idea here is this follow the aim of this follow loop is we will go to each bit. Okay. Bit number 0 till bit number 29 will go for this particular value. Okay. We'll go through bit number 0 till bit number 29. Okay. For this particular value. Okay. For this particular value, and we will see which all bits are set. Once a bit is set, what we will do, we'll go to that particular key. Okay. We'll go to the key which represents that bit, and we'll increment its frequency by one. We'll decrement its frequency by one. Okay, as per the case. In this case, we decrement the frequency. In this case, we're incrementing the frequency. That is the basic idea. Okay. And if the even after doing the increment or even after doing the decrement, if the array is still a nice array, at last we have to return that value also. Okay, whether after the increment or the decrement it was still a nice array or not. So this part is something that I have not explained you fully, but I am see since I guess in January we had a week full of bit manipulation questions. That time we had done a lot of these things. Okay, so that is the expectation. If you are watching my videos from a long time, I'm sure that you would have learned this thing properly at that time itself. Okay, that's why I'm not focusing too much on this, because this question needs your attention in different part. Okay, that's why I cannot like keep explaining this part itself. This question is slightly above this. Okay, you should be knowing this in order to solve the current question. Okay, this thing is not the primary on the aim of this question. This question is not the primary problem of this question. The problem is different. This part is needed to solve this. Okay, so this is the only part that I felt you may not be able to understand if you don't have the right background in the bit manipulation topic, if you don't have the right experience in a bit manipulation topic. So practice these things. I'm sure you will be able to quote it further. Okay, when it comes to the next time. And the next thing will be, if you are new, my recommendation to will be try to understand how the binary representation, how they represent it. Okay, try to learn what is two's complement and all those things. Okay, because they are, see, you have to understand first like how these are represented. Okay, and same thing like these calculations, again they're very important. No one will show them. Okay, even when I was learning, I did not find it anywhere. I had to myself learn how these things are coming. Okay, they will just write somewhere, okay, the 30 bit should be enough to have this number, but how these numbers are coming, you see, I did, like, I knew the maths, but I just had to find like how to use it. Okay, simple as that. I knew the maths, but the only thing is we have to know, like, see, every number is stored in a binary bits, right? So always whichever number you want to store, it should be in the form of a bit only. Okay, so that's why you have to do this particular calculation and you have to get this number. Okay, once you get this number, if you see this particular value, I'm using in all my calculations. Okay, if you see here also, I'm using it till 30. Here also I'm using it till 30, because the numbers that are going to come for this input will not exceed this particular value. Okay, so for this particular value, 30 bits are more than enough. Okay, as simple as that. So yeah, that was all for this particular video. So if you have anything to tell, please do comment below. I go through every comment, and always I try to reply my best to all the comments. And if you like my efforts, if you like the quality of this content, please subscribe to the channel. This really gives us a lot of motivation to continue further. I am about to complete 150 days. Okay, I am about to complete 1000 questions also in LeetCode. So let us see how many more days we can continue like this. But yeah, if you are getting some benefit, if you are getting to learn some things, my aim is, see, not everyone have the access to quality paid content. Okay, even when I was a student, I was not having the access to some paid content. Okay, that is the reason why I felt what I have learned till now. Okay, with all the struggles, with all the late nights, staying awake and learning it, whatever I have learned, I want that to be useful for someone who cannot afford paid content. Okay, that is the reason why I am making these videos. I may not be the best speaker, I may not be the best teacher, but again, what I can tell you is that I am showing you the full content. Okay, whatever I have learned till now, okay, based on my experience. If you believe that, okay, see, one thing I can tell you, my aim is whenever a question comes, I am telling all the things that I would have told to interviewer if this question had come. Okay, so that is my aim, that is what I'm trying to teach you. Okay, all these things, see, these are important. Okay, people will not tell you, people will try to make good videos which are appealing and all that. My aim is not to make appealing video. My aim is to go through every detail, so that, see, always in YouTube the best thing is you can pause, you can rewind, and you can obviously fast forward if you're not, if you know something already. So those things are already there. Okay, so please use this platform in a proper way. Okay, definitely my only thing is, all the content that I'm making, I ensure that it's a complete content, it's not half content. Okay, if, like, say, let's say for this particular part, as I mentioned, I'm not covering it here in this video because I've already covered it somewhere else. Okay, so that's why I'm telling you there the same thing also. Try to learn what is this. If you're not aware of this, then pause here itself. First get a full understanding of this, then continue with the video. Okay, that's what I'm trying to tell you. So yeah, friend, that was all for this particular video, and please subscribe if you like this content. See you tomorrow. Thanks a lot.